All right, time for the last page. Here we go. Sorry, I gotta get this thing to actually accept my share screen. There we go. All right. So obviously, I think we're looking at both of these problems, that conjugate trick where we see the square root. So let's go ahead and distribute a root x plus 2 top and bottom. Now remember, this entire thing is about fixing the fact that when we plug in the number 4, we get 0 on top, we get 0 on the bottom. This is, again, an indeterminate form, so we know we're in good shape. Okay, so let's see what happens. So I've got x minus 4, and then I got a root x plus 2. Notice that I did nothing to the numerator because I'm hoping that I can make that denominator cancel out. Now, when I do this, root x times root x, of course, is x. The outer and the inner cancel, but I got a minus 4. And so what's really nice about this thing is that you can see that those two things cancel out. So as I get infinitely close to the number 4, I get root 4, which is 2, plus 2, which is, again, 4. Now, I will admit I myself just looked at this problem in the past and just put my head down and just kind of went for it. But if you plug in the number 1/2, 2 times half is 1. 1 plus 3 is 4. The square root of 4 is 2 minus 4 over 0. Well, what you're going to notice is this is not 0 divided by 0. That means this limit does not exist. I do not have to actually keep going. There's going to be a vertical asymptote at negative 1/2, or excuse me, at positive 1/2. I don't even need to worry about it. I'm going to quit. I actually did some work last time I tried that problem, and then I got myself stymied because I went through the math, and then 2x minus 1, in fact, didn't cancel out because I didn't pay attention. All right, moving on. A problem that we've already seen a couple of times in this particular review, the fact that we have a 9x here means I need a 9 to match that. So in order to put a 9 in the bottom, I must also put a 9 on top. We already know that the sign of anything divided by itself is going to be 1 around specific, not every time, but around the number 0. That's true. So 9 times 1, of course, is 9, and we are done. Moving over to here, they're playing with something just a little bit, but what you might notice is this is a difference of squares. 1 is 1 times 1. Cosine squared is, of course, cosine times cosine. So I'm going to go ahead and utilize the fact that I have a difference of squares, 1 plus the cosine times 1 minus the cosine, all over 1 plus the cosine of 3x. And what we'll notice is those two things cancel out. Now, what's kind of nice is when we were looking at this right here, we have 1 minus the cosine of 3x over 3x. Well, this is one of those really, really nice ones that I haven't made as big of a deal out of. In fact, I just messed that up because there was no 3 there. I wanted the 3 there, so I'm going to put that in front. But this is one of those cases where this is a special story. 1 minus the cosine over the same value is going to be 0. And so that's the secondary one. These are the two versions we're looking at. And moving on, we have the limit as x goes to 0. Sorry about my limits being so sloppy. And I've got this right here. So this is one of those problems that we've done quite a few times. I know that I need an x on top and bottom to match each of these particular signs. This guy needs a 9 on top. This guy needs a 7 on the bottom. And so we've got 7 9s. We know that each of these limits right here is 1. So we're looking at 7 9s. And we're getting there. Moving over to here. We are looking for a cosine. So I'm going to go ahead and let's factor that cosine out. So if I factored a cosine out, we're looking at this over this. Well, yet again, this is the perfect value that I was looking for. This particular limit right here, as t goes to 0, is 0. And as t goes to 0, the cosine of 0 is 1. So 1 times 0 is 0. We're done. Easy peasy. Now, E is tricky because there's nothing there that really obviously makes it true. Because if I plug in 0, I do get 0 on top and I do get 0 on the bottom. So I know it's one of these special cases, but there's nothing that jumps out at me. So I'm going to try a little trick that we did last year when we did a little bit of trig proof. This should ring a little bit of a bell, but I'm going to multiply the top and bottom by 1 plus cosine. That's going to lead me to a little nice thing here, because 1 minus cosine times 1 plus cosine is 1 minus cosine squared. And let's keep going. And I now know that if you go a little bit further, 1 minus cosine squared is specifically sine squared. And so I'm going to go ahead and instead of writing it as sine squared, I'm going to write sine times sine. Now that's the numerator. That was sine squared. This is not a proof, so I can kind of be a little bit quicker. Now I've still got my sine from the denominator, and I got my 1 plus cosine. Now we do know that those do in fact cancel out as long as I don't literally plug in 0. As long as I'm infinitely close to 0, they do cancel. But now as you go close to 0, the numerator is getting very, very close to 0, where the denominator is actually getting close to 2 because the cosine of 0 is 1. So 0 divided by 2, in fact, is 0. So the limit of this crazy thing in this case is 0. And last but not least, we've got letter F, where they handed me a tangent. Interesting. So let's check out the limit as x approaches 0. And let's rewrite this as a sine of 4x and a cosine of 4x. And like I said, I just tend to like to kind of break things up a little bit. And for the denominator, I'm going to throw the x in front, x here, but I'm going to leave the 7 out in front because I want everything to match up. So the only thing I really need to make things absolutely perfect is I need a 4 in the bottom and top. And then I think I'm good to go. So I've got my 4/7 here. I know that the limit as x goes to 0 of this particular quantity is 1. And nice enough that as x goes to 0, the cosine of 0 is 1. So this fraction is 1 over 1. So it looks like my entire limit is, in fact, just plain old-fashioned 4/7. And we have completed our review. Hopefully that's helpful and you'll feel a little bit better prepared as we're working towards the exam. All right, I'll see you back in class. Bye-bye.